In this video, we're going to be looking at the structure of the atom and how Rutherford discovered this with his scattering experiment. In 1910, Ernest Rutherford decided to investigate the structure of an atom. He noticed that atoms gave off alpha and beta radiation, so these particles must have been smaller than the size of an atom. Because they're smaller than the size of an atom, they could have been used to discover the size and structure of the particles inside. This is the experiment that he devised. He found a source of alpha radiation and decided to fire the particles at a thin piece of gold foil. Gold foil is quite unique in that it can be rolled incredibly thin, so this piece of gold foil is actually only a few atoms thick. He decided to fire the alpha particles at the gold foil to see what would happen, depending on the results that would tell him about the structure of the atom. So this is what he saw. He started to fire alpha particles at the gold foil, and he noticed that some of them were deflected slightly when they hit the gold foil, some of them were deflected by slightly larger amounts, this particle here, but the vast majority of the particles went straight through the gold foil, experiencing very little or no deflection. A very small number, around 1 in 8,000 particles, were reflected straight back towards the source. So most passed straight through with only a small deviation. Some of the particles had a slightly larger deviation, and very few of them deflected straight back to where they came from, around 1 in 8,000. So his observations were that most of the particles passed straight through, deflecting by no more than a few degrees, and a small fraction of the alpha particles were reflected straight back towards the source. Using those two pieces of information, he was able to determine what the structure of the inside of an atom was like. This particle here was reflected away from the gold foil. It was repelled by it. Alpha particles are positively charged. That told Rutherford that the atoms inside the gold must also have an area of positive charge. Remember that two areas of positive charge repel. If the alpha particle was negative, it would have been attracted to and stayed inside the gold foil. This also told Rutherford that the inside, that area of positive charge, must have a lot of mass. To be able to reflect one of these particles straight back, that area must have had a significantly bigger mass than the alpha particle, so quite a large mass. If the gold atoms were really big, then very few particles would have been able to travel through the gold. Watch what happens with these very large atoms of gold. Very few of the particles actually get through. Most of them are reflected back. Rutherford's results showed that most of the alpha particles travelled straight through. This told him that the area inside the atom, that area of positive charge, must have been quite small, despite the fact that it needs a lot of mass to be able to reflect these particles back. So in reality, this is what an atom looks like. Most of the atom is empty space, and inside there's an area that's quite heavy, got a lot of mass, but also is really positively charged. So when these alpha particles are fired through, most of them travel straight through, some get a slight deflection, and very few of them are reflected straight back towards the source. This is because the nucleus is very small, so most can pass straight through. The rest of the atom is empty space, and the nucleus is also really strongly positively charged, so it's able to repel those positively charged alpha particles back towards the source. The nucleus also needs to have significantly more mass than the alpha particle, otherwise the nucleus would move and the alpha particle would stay where the nucleus was. Please note though that this isn't to scale. The nucleus of an atom is around 100,000th the size of an atom.